Over 2,000 years ago, before we had satellites, GPS, or space travel, one man stood tall in ancient Alexandria and cracked the code of our universe. Eratosthenes, a genius who dared to measure the earth, the moon, and the sun, armed only with shadows, sticks, and an insatiable curiosity. How did he do it? Join us and unravel the mystery of the man who sized up the cosmos. Eratosthenes' methodology to calculate the Earth's circumference was simple, yet scientifically brilliant, and deserves a more detailed explanation. His approach began with an observation in the city of Syene, which revealed an intriguing phenomenon. At noon on the summer solstice, objects cast no shadow there. This detail, along with the fact that the sun's rays reached the bottom of a deep well, signified that the sun was directly overhead at that particular moment. In contrast, he noticed that at the exact same time in Alexandria, a city located approximately 800 kilometers to the north, a vertical stick did cast a shadow. This discrepancy led Eratosthenes to further probe into this phenomenon. Arriving at Alexandria, he undertook the task of measuring the angle of the shadow cast by the vertical stick. This process involved setting up a stick vertically and then measuring the length of its shadow. He then used simple geometry to calculate the angle formed by the shadow and the stick, which turned out to be about 7.2 degrees from the vertical. Eratosthenes then theorized that this angle was identical to the angle formed by a line from the sun to the center of the earth, and a line from the center of the earth to Alexandria. This hypothesis was based on the principle that the sun's rays are parallel when they reach the earth. Having established this, Eratosthenes then used his knowledge of geometry to calculate the Earth's circumference. He understood that a complete circle consists of 360 degrees. Thus, by dividing 360 by the shadow's angle, he deduced that the Earth's circumference was approximately 50 times the distance from Syene to Alexandria. To obtain a numerical value for the Earth's circumference, Eratosthenes multiplied the distance between Syene and Alexandria by 50. This led him to arrive at an estimation of the Earth's circumference to be around 40,000 kilometers, a value that's astoundingly close to the actual figure known today. This method showcased Eratosthenes' remarkable scientific acumen and paved the way for future geographical and astronomical calculations. Having determined the circumference of the Earth, Eratosthenes then embarked on calculating the diameter of our planet. To accomplish this, he took the circumference and divided it by pi, which resulted in an approximate diameter of 12,800 kilometers. Not stopping there, Eratosthenes moved on to measure the moon's diameter using a unique and innovative approach. His method involved observing a lunar eclipse, more specifically when the moon passed through the Earth's shadow. This gave him a comparative scale between the Earth and the moon. By taking into account the relative sizes and timings involved in the lunar eclipse, Eratosthenes was able to estimate the moon's diameter. His findings were remarkable. He concluded that the moon's diameter is approximately 1/4 the size of the Earth's. Thus, from these observations and calculations, we get a sense of the relative sizes of these two celestial bodies. Eratosthenes, a brilliant mathematician, embarked on a groundbreaking endeavor to calculate the distance to the moon. His approach was ingenious, utilizing the natural phenomenon of a half-moon. At this phase, the Moon-Earth-Sun angle is precisely 90 degrees, a perfect right-angled triangle that Eratosthenes cleverly exploited to his advantage. By applying principles of simple geometry, he was able to estimate the distance to the moon. The process involved taking the Earth as one point of the right-angled triangle, the moon as the other, and the sun as the hypotenuse, and utilizing the trigonometric ratios that apply in a triangle of this nature. With the application of these geometrical principles, Eratosthenes was able to establish a rough estimate of the lunar distance. His meticulous calculations yielded a remarkable outcome. Eratosthenes concluded that the moon was approximately 60 Earth diameters away. This figure was generated by considering the Earth's diameter as a unit of measurement and determining how many such units could fit into the estimated distance to the moon. As such, Moon's distance was approximately 60 times the diameter of the Earth, a testament to Eratosthenes' mathematical prowess and innovative approach to understanding our universe. Having obtained the distance to the moon, Eratosthenes turned his focus towards calculating the distance to the sun. He based his approach on the angle formed between the sun and the moon during an eclipse. With the knowledge of the size of this angle, and combining it with the known distance to the moon, Eratosthenes applied principles of trigonometry to ascertain the distance to the sun. His calculations didn't stop there. Once he had figured out the sun's distance, he went on to calculate the sun's radius. He did this by considering the angle the sun forms with the Earth and the known distance to the sun. In summary, Eratosthenes' innovative use of angles, distances, and trigonometry allowed him to calculate not only the distance to the sun, but also the sun's radius. In conclusion, Eratosthenes' legacy goes beyond the realms of geography and astronomy. His critical thinking and innovative approach to understanding our world has shaped how we understand the universe today. He was not only a pioneer in his field, but also a testament to the boundless potential of the human mind, even when faced with the vast unknown. Stay curious and keep learning. Until next time.